Hello guys, hi. Nice to see a lot of amazing audience around it, and thanks Pawan for the great introduction into data streaming and why it's needed. So we'll take a little more deep dive into how one of these streaming softwares, what we call Kafka, works, right? And we'll be discussing a bit about Kafka, Kafka Connect, and very nice use case which comes out of Kafka Connect, which is capturing change events which are happening on databases. Right. So quick introductions. So hi, I'm Chaitanya, and I'm working at Confluent for the past 3 years, and mainly working on Kafka Connect team here. And I've developed a few connectors and done a bunch of monitoring and security improvements on Kafka Connect on cloud, which is served by Confluent. And so super excited about data and distributed systems, cloud architectures, and I think Pawan did a great job introducing all these three ideas when it comes to what's the current state of things of data. Right. All right. So today's agenda would be I'll start with Apache Kafka and Connect, give a brief introduction of what it is, why it's needed, and how it ties into the streaming industry today. We'll then move to the change data capture notion, which is basically what we'll be mainly focusing on today. And then we'll look at a few interesting architectures this CDC allows us to achieve at scale, right? Both on the analytics side as well as software engineering side. And if time permits, we'll do some hands-on. Yeah. And let's try to keep the Q&As towards the end, since we have some packed agenda, and I would try to want to give most information first. All right. So let's start. So what is Apache Kafka? So Apache Kafka is an open source distributed event streaming platform. And it's typically used for high performance and real-time analytics as well as real-time data pipelines. Uh, Too many buzzwords over here, but let's try to break them down slowly. We just discussed about events, right? I mean, how Pawan kind of introduced events. Events are everywhere. And to simplify it, what's an event? And sorry. All right. So yeah. So I was saying let's dissect this down and let's look at events here. So simplest definition of an event would be it's any type of actionable data. So for example, a payment or a click on a website, right? And with these events are associated information what happened during that event. So where these events come from? The events could be coming from what we call sources, right? They could be coming from databases. So maybe your payments have been stored in the databases, or it could be search indexes or file system. You have your logs in your file system. Maybe each log line in the logs file system log is the event for you, right? Or it could be from your cloud stores like S3 and blob stores, whatnot, right? And typically, these events are destined to a sink, and sinks could be somewhat like OLAP stores. I mean, a bunch of data stores, data warehouses, all of those, right? And there could also be cloud functions, right, where an event should be triggering a downstream job or downstream effect, right? And similarly, they could still be databases over here or some other SaaS systems, like Apache, ClickHouse, all these places where you want to store your data and do some analytics on it, right? So now that we have these events, Kafka stores these events in a fault-tolerant manner. Rather, now that we know Kafka is a distributed system, Kafka cluster stores this in a very fault-tolerant manner. And producers are clients for Apache Kafka, which lets you get these events from the sources and write it to the Kafka cluster. And consumers will be consuming these events from Kafka and could send it down to the sinks. And all this allows us to do real-time processing. Not too many words. Let's look at an image that makes it much better. Right? So here, what we have today is Kafka in the center. Uh, so we have Kafka in the center, and rather we have a Kafka cluster where it stores logical entities called topics, and topics are where records or events are stored. And topics could be somewhat similar to your tables in our databases, right? And the producers are producing data to these topics, and consumers are consuming the data from this topic. So very interesting, patterns emerge here, right? If you see, Kafka very nicely logically separates the producers from the consumers, and in fact, multiple producers can be producing to a single topic, and multiple consumers could be consuming from a single topic. So you could have an application on your side, like let's say you're trying to get data from a database. So you could have multiple producers reading from each table and producing that data to Kafka. And at the same time, the same data could be read all by these consumers, and that could be sent down to the sink. So if you imagine, there's a very nice pipeline being built out of it, right? So Kafka lets you, move the data from the sources to the sink. And this is what we call streaming. And Kafka lets you allows you to do all this at real time. So coming back, right? So you can see Kafka is a distributed event streaming platform. This is what I was talking about. All right. Now that we know what Kafka is, and you can see there are so many sources, so many sinks, right? And uh, is it just enough just to use your common producers and consumers to get data from these sources and send it to sink? Uh, Probably not, right? Why? Because you have so many sources, so many sinks. A few ideas become very clear, right? So whenever you're trying to stream data from the sources or trying to send it to the sink, you need a scalable system to do that because you never know what's the scale at which your database is operating, or you never know what scale at which your cloud functions are going to function, right? So you need a scalable system for any kind of source or any kind of sink. You want it to be really fault tolerant and to be able to recover quickly whenever any fault occurs, right? And at the same time, the movement should be extremely reliable. So this kind of kind of gives us a way that we do really need a system over here to allow us to do all this, right? You can't keep reinventing the wheel every time you have a new source, new sync, write the producers again, write the consumer applications again to get this data. So this is where Kafka Connect comes into picture. So Kafka Connect is part of open source Kafka distribution, and it's a distributed framework that hosts services called connectors, and it gives us an ecosystem of source and sync connectors. So we discussed about what source and sync are, right? And these connectors can do checkpointing, so they can recover whenever there's any fault or whenever they fail. And this Kafka Connect framework kind of gives you way to assign work to these connectors and balance them over the cluster which Kafka Connect holds. So again, let's take a look at an image to make this more simpler, right? So the older image kind of gets a little more simplified over here. So what we have today is data source and the source connector which is streaming this data to Kafka, and the sync connector which is reading the data from Kafka and sending it to data sync, right? So as you might all imagine, there are producers and consumers beneath source connector and sync connector, except Kafka Connect gives a very nice abstraction to abstract this out and not think about the producer and consumer semantics. Very low level semantics when it comes to Kafka. So, but this is a very nice image when you want to look at it and understand what's happening. But if you click down, as we discussed, we have our Kafka Connect framework, right? So we have a Kafka Connect framework where you have workers running, where the tasks or the connectors are basically the unit of work is scheduled. In this case, let's say the worker one is running a source connector, which is reading data from the data source and sending it to Kafka, while sync connector is on a different worker, which is reading this data from Kafka and sending it to data. All right. So we discussed Kafka and Kafka Connect. So just to recap, right? Kafka is an event streaming platform, and Kafka Connect lets you bring these events to Kafka and take events out of Kafka. So this is how the streaming ecosystem around Kafka Connect is built, right? And as we progress, we'll try to pick up a use case, which is CDC, and then we'll also look at a few architectures, how this comes into picture. All right. So next up, let's start with what is change data capture. So change data capture, or what we call CDC, isn't a new thing actually. It's been here for ages, maybe 20 years. The last time, the first paper which was published was around 20 years ago, which describes this term called CDC. But what is CDC? It aims to capture all the changes in the database in real time. And what are these changes? These changes are like insertions, deletions, or changes to the schema, etc. And CDC, as we say, right, it very nicely architecturally decouples the production database from multiple use cases. Okay, what are these use cases we are discussing? If you see, there are always use cases like analytics. You want to audit the database, or you want to replicate your database. So what CDC lets you do is you kind of decouple it from the production database. So all of your other use cases are kind of separately distributed amongst the teams, and you don't need to do everything together, right? And so yeah, how do you do the CDC? So CDC is typically the extract load part of your ETL data pipeline. So all the databases have transaction logs which store as events occur in the database. So for example, Postgres has something called read ahead log. So whenever there's an insertion happening in a database, or whenever there's a delete happening in a database, and record gets stored into this transaction log. So what we do is we try to tap into this transaction log and get these events. And the load part is basically trying to get this data into a common location, which could be S3, which could be a data warehouse, or even Kafka today, right? So let's take a step back, right? We just discussed about Kafka Connect and the framework, and something really looks very similar over here, right? So both this extract and load can be done by a source connector, right? because the source becomes your database and your store becomes your Kafka. So source connector could be reading this data from this transaction log and sending the data to Kafka. So this is exactly where Debezium connectors come into picture. And Debezium are a set of open source connectors which let you stream changes happening on databases, all the history events happening on database to Kafka. And all this is done, each change is recorded as an event in Kafka. And that could be used in processing downstream and any other sync, right, for example. And all this, since this is running on Kafka Connect, all of this can happen, in a real time and very resilient and reliable fashion. So again, let's take a look at the image, right? So you have Kafka Connect over here, and that's where Debezium is running. So this is the logo for Debezium, and you have Debezium connectors running on Kafka Connect, reading from multiple relational databases, and all the changes happening on this database is getting streamed to Kafka. All right, so amazing. So what we learned about Kafka, we learned about Kafka Connect. We also learned about use case called CDC, which is change data capture using Debezium. So now we have all of our pieces set up in the puzzle, right? We have our architecture set up. It's not as simple as that when it comes to production. But for today, let's say we have our Kafka setup, we have our Kafka Connect setup, and we have our CDC connectors in picture, right? So now that all this is set up and we have our data, right? How does this data flow through our system? And how do we use it, right? So in the next few slides, I'll be looking at a few architectures and use cases where CDC comes into picture. So the first one I'm going to discuss today is very simple one. It's a very common use case as well, as we see very recently, right? As database migration. So what we want to do is it's more of a ETL kind of a model where you want to keep a source and a sync system, sync database in sync, right? And when do you want to do that? Some typical use cases could be you're trying to migrate off a existing database. So you have an Oracle database. Now you realize, Postgres is the shiz, and that's the best database you could have for your system. You're trying to move from Oracle to Postgres. Maybe you want to do disaster recovery, right? So you have Oracle database in your East USA, but you want to start replicating that data to India. And that's why, you want to kind of do these decoupled activities so that your data is always replicated and there's a disaster recovery instance available here in India. Or maybe you want to just have multiple databases in your architecture, right? That's not a uncommon case as we see, as we're going to see in the next architecture, that there could be multiple databases in your production system which are actively serving the customers. All right. So this is a very simple architecture, how it would look like, right? So what we have over here is, like we were talking about the case of Oracle database and Postgres, right? So you have Oracle database and you have Debezium connector running on Kafka Connect. What it does, it streams all the events as they are happening on the Oracle database. So let's assume a case, there's an insert happening to this Oracle database. The Debezium connector in Kafka Connect picks it up immediately, sends it to Kafka. And on Kafka, you could be doing some kind of processing, right? You might want to, the data types may not be compatible. So you might want to do some transforms before sending it downstream. So once you do those transforms, use multiple ways to do that, right? We discussed about Kafka streams and we discussed about KSQL. There is also Flink, which lets you do it. So here I've just put an image of Flink, which lets you do stream processing. So you transform that data and then you send it downstream using a different connector. In this case, there are other open source connectors like JDBC connectors, which let you sync this data to a sync database, which could be Postgres. So as events occur over here, so once an insertion occurs here on Oracle database, it goes to Kafka, it gets processed immediately, and then a different connector writes it to Postgres. And all of this happens near real time, right? So any change happening is available over here and you're ready for your database migrations efforts, right? So again, this is not something which I'm like cooking up on there. These are some architectures which are being used in multiple places. For example, Stripe is a US company which does a lot of payment activities here, and they have been using this kind of architecture to send their data from their production database to their other databases in their clusters, even a few production databases as well, through such an architecture. But like let's take a little more deep dive, right? Now that we have an architecture, what more can we do? So the next architecture or next pattern, what we call is, I'm going to look at is a more of a software side pattern, not a data side pattern, right? So typically companies start with monolithic architecture, stuff everything you have in one single piece of code and everything works well, right? It's serving all the customers perfectly, all that. But as the scale increases, you realize there are multiple components which need to scale independently. And the strangler pick pattern very nicely gives you a way to move your functionality from a monolithic application to a microservice application very gradually. And so again, in production, this is not easy, right? You can't just hard cut off and say, oh, my monolith dies and my microservice comes up, right? There needs to be there can't be downtime. You want to slowly migrate off your users. You want to make sure everything works fine in your new architecture. And that's the reality. While on paper it says, okay, microservice monolithic, but yeah, you need to have a migration pattern. How do you migrate from an existing system to other, right? So how this happens is you slowly evolve this. You have three things which you do, which is one is extract, next is coexist, and followed by eliminate. So let's take this case, right? So again, following up, right? We have an Oracle database over here, and we have a monolith system which has an order component, a payment component, and warehouse component. So we want to kind of move out our order component because we're seeing a lot of orders and we want to scale it independently. So we decide we need to do a microservice out of this guy. All right. So that's the extract part of our job. So we'll start there. All right. So we have extracted our order component out, and we have an order service over here. You guys can see the screen fine, but I hope it's not too bad. So we have an order service over here. Now that we have a service, let's start slowly migrating off, right? Let's try to coexist with the existing monolith, and let's see how we can do that. So we can start serving the read request from this new thing. Let's not do the write request because there's a production database available for us. So we'll start doing the read request from from this from this microservice. So what typically people end up doing is putting a proxy in front of it, and you do the write request to the monolith while the read request will go to the newer service. And amazing, but how do we make sure that we can also start doing write requests, right? So that's where our data migration architecture, which we discussed, kind of comes into picture beautifully. So let's say this new microservice has its own production database, where because it's a huge database, right? We decided no, we want to go for Postgres that supports much better scale and much easier queries for us to do, right? So we start using Postgres as our production database for this order service. So what we start doing is whenever there's a write event happening, we try to flow it from the Oracle database to the Postgres database using the previous architecture which we discussed. So we have our Debezium connector running over here, looking at all the changes happening in Oracle. It goes to Kafka, and from Kafka it goes to Postgres. So order service can actually start, sending out live requests, read requests back to the customer. Now, how do we do writes, right? That's the next step, right? Like we're getting closer to eliminating this out. So how do we do writes is where we start a reverse pipeline. So we have a Postgres connector over here, Postgres Debezium connector, which is reading the events, write events happening in Postgres and start flowing it back to Oracle. I mean, why do we need to do that? Because both payment or the monolith still depends on the data from order services. So as we slowly start picking out, there might be a time when the Oracle database does not need any of this data. So this is a nice pattern which is used in production called Strangler Fig pattern. And let's take questions from it. And yeah, this is something which MongoDB had to do in their activity when they were trying to move from their monolith to a microservice-based architecture when they were providing their cloud platform. All right. So let's move on to the next architecture. And this is more on the data side, right? There's a very interesting use case which is being picked up more recently, and what it's called is user-facing analytics. So what is user-facing analytics? Companies want to provide a feedback to the user whenever they're using their application and all, right? LinkedIn, Google, Swiggy, all of these guys kind of provide some real feedback if you have seen or not. For example, LinkedIn exposes how many people have viewed your profile, and or Facebook exposes user engagements, right? Or even Twitter today, right? You can see how many posts, how many people have seen your posts. And Swiggy and Zomato exposes, your real-time estimated arrival for your, delivery even before you end up the order. All of this, if you want to do it real time, it's not possible with our traditional architectures, right? So that's the use case of real-time analytics. And yeah, Batch and OLAP Store do not suffice it. So maybe with the time, I'll just go to quickly skim over this architecture. Actually, this is from a blog from StarTree, and I know I think we have Suraj here and Saurabh who are going to discuss more about Apache Pinot and probably covers similar ideas there, right? But yeah, this in this small architecture, what's happening is let's imagine a service like Airbnb, which has a booking service, right? So an end user ends up querying the API for booking a place. And what happens next is this data is written to MySQL, and Debezium streams this data to Kafka. We are very familiar with this kind of architecture. Now, this data can be ingested by real-time services like Apache Pinot or ClickHouse or even Druid, right? I'm sorry. And that serves as a front end for analytics service, and that is also part of the API service where the user can query these API. So we are actually bringing the analytics closer to the user. If you see earlier, analytics used to be a very business use case where data engineers are crunching data, trying to get some business insight, and then go back to their managers and figure out what needs to be done. But here we are bringing analytics as close to users as possible. And this is a very nice architecture which has started popping up very frequently in a lot of these new age things like that. And yeah, and you can do a lot more transforms around over here as well. Do we have some time for demo? Should we take some questions? Yeah, yeah, we can take some questions. I think, yeah, the question. Yeah, we can do. Yes. Sorry? Correct. So you'll slowly start cutting off your requests from one service to the other service. So some requests are routed here, some are routed here. Oh yeah, that's where the proxy kind of comes into picture, is where you decide, okay, some 50% of my requests will start going to this, 50, rest 50 will be going to this. Oh yeah, I think that's the interesting thing, right? That's where probably the processing comes into picture, maybe tagging to make sure that this information has been already presented over here. And yeah, that's actually a very interesting question. We should see how we can. So connectors, actually, the aim of connectors was to keep it as simple as possible to get this data, right? And then use streaming platform on Kafka to do it, like Flink or data streams or whatnot, right? But there is a part of Connect which is called transforms, which lets you do single transforms, right? So you have a record and you're very sure you don't need certain fields of it. You can just do it in the Kafka Connect or the connectors itself. So you can write some custom transforms to do such kind of trimming per event. But if you have a large scale processing which requires some kind of join or multiple use cases like this, it's better to do it on Kafka and user streaming. You have a question? So, 2x in the correct. Yes. The CDC format for Oracle would be different from that. Oh yeah. How does correct. Is there an intermediate component in yes. Yeah, yeah. So that's something which I've had to abstract out. So so Kafka Connect has has a way it understands records. I mean, it's a more implementation detail, but it has a schema and a record format which is common for all the connectors. So it makes it even more interesting. So the data you're looking into Kafka will always have a very similar record pattern from any source or any sync. So it makes these pipelines even more easier. So whenever CDC is being read from Oracle, you try to transform it into a way which looks like a connect record, and that's stored in Kafka. So that can be easily be understood by any of the sync connectors. Okay, this is a record which I understand. So since there's a schema also associated, so you can also associate each row saying that, okay, this is an integer type column or this is a string type column. So that gets translated on both ends. So Oracle might be having something like a numeric data type and probably Postgres has a decimal data type. So that transformation also happens in connectors. So I mean, that's probably one of the even more important reason why connector framework kind of came into picture, because you want to make sure these pipelines are very seamless. It's I mean, if you look at the client, if you look at Kafka, Debezium would be a client for it, but it's mostly in the client. No, so basically how Debezium works is a poll-based thing, so it directly connects to a database. You don't need to install it on the database, but what you need to do is you need to make sure that Debezium connector is available in the Kafka Connect cluster where the connector is running. The other way around, Debezium is a plugin for Kafka Connect. So Kafka Connect is a framework where you can run connectors, and Debezium is a kind of connector. So Debezium is a plugin for Kafka Connect, and that lets you get data from or databases to the Kafka. Server for yeah, sorry. Can you repeat?
should be the one which is pulling the data from Oracle.
It's pulling the data from Oracle, yeah.
And internally, Kafka Connect will be using Debezium.
Yes, Debezium connector, and that will be writing to Kafka. So actually, in both the sides, it kind of acts as a client itself because you're querying the database, right? So you're acting as a client to query the database for changes, and you're also a client to Kafka because you're writing to Kafka. So Kafka Connect is while it's the connectors mostly tend to be client based. Sorry. Yeah. No, each connector would either be a source type or a sink type. And source connectors would have producers because they're trying to produce to Kafka. Sink connectors would have consumers because they're trying to consume from Kafka and press it. So Debezium only provides source connectors. Sink connectors, the other open source sink connectors which let you write to sinks.
Is there any concurrency set?
Sorry?
Concurrency. Can you set the concurrency of nodes?
Yeah. So I mean, is concurrency or parallelism? Yeah. So in case of Debezium and the parallelism is at the table level. So Debezium can stream, can start recording data from each table. So parallelly, you could, if you have hundreds of tables, you could start recording data from parallelly from all these 100 tables. Just short of time. There are a few more questions here. Sorry. So it does, basically, Debezium does let you kind of detect transactions on the source side, which is on Oracle. But it kind of depends how you describe this transaction support. I would say out of the box it doesn't, but you could build your streaming application to support transactions. Correct. Yeah, so if that's the implementation detail, you could make sure that this is happening transaction by transaction, or you could also do asynchronously as well. But the data would be coming to Kafka asynchronously. Once it's in Kafka, you can figure out there's a transaction, but it will be synced asynchronously. There's a few questions behind it, yeah. Sure, yeah. Correct. Right. Right. Yeah, so typically we try to separate these two ideas, right? So when connectors come into picture, it's just streaming of data and no analytics or no pipelines happening in picture, right? So when I'm talking about checkpointing, is mostly for fault tolerant. Like let's say in your case, there's a OLAP store where you're trying to get data from, like maybe Snowflake or maybe some other place, right? You're trying to get data from. You'll try to checkpoint and say that okay, I've read up till this point. I've read up till row number 45. So if I fail, I come back and start from 46. So that's the kind of checkpointing I was discussing about. Does it answer your question somehow? Correct. Correct. Yes. Okay. So, yeah, maybe let's take this question offline. It's easier to discuss in person. Are we out of time?
Yes. I think we can take the rest of the questions.
Yeah, let's do it later, right? Like we can connect later. Okay, thanks. I just. Yeah, so there is a QR code if you guys want to pick up the slides and follow.
Also, we'll be sharing these slides over the meetup in case you want to.
Yeah, quickly. I'll just wait for a second.
Thanks, Chaitanya, for such a wonderful.